figure shows a square of a wire having total resistance R that is placed coplanarly with a long straight wire. Let's say this is my straight current carrying conductor. A square loop having a resistance R. This distance is B. Edge length is A. And this is the current I. Now first case, we have to calculate the EMF induced in the frame. Fine. The first thing we have to note here is that magnetic field due to a straight current carrying conductor is given by mu naught I by 2 pi R, where R is the distance, perpendicular distance from the current carrying conductor. Fine. Now another thing is that by right hand thumb rule I can calculate the direction of magnetic field. Now if this is the direction by right hand thumb rule, the direction of magnetic field passing through this loop is inside. Okay, now we have to calculate EMF, that is given by minus d phi by dt if we talk about magnitude, and flux that is passing is given by B into A. Now the problem here is that magnetic field through this square loop is changing because it depends on R, as we wrote here, and the R is changing from this point to this point, and so the magnetic field. So what we do over here is we take an elementary length, let's say of width dx, at a distance of x from the current carrying conductor. So this d phi, that is the small flux passing through this elementary width, is given by magnetic field, that is mu naught I by 2 pi x into area. Area is length into breadth, that is A into dx. Integrating both of them, the value of x varies from B to A plus B. So we have mu naught I A by 2 pi natural log of x, integration with limits are from B to A plus B. So on solving this, I get the total flux. I have mu naught I A by 2 pi natural log of A plus B by B. Fine. Now here is my flux. I have to calculate EMF, that is given by d phi by dt. So it can be written as mu naught I into A into 2 pi natural log of A plus B by B d by dt of it. Okay. Now since I is changing over here and rest of them are constant, so I can write mu naught A by 2 pi natural log of A plus B to B di by dt. So we have mu naught A by 2 pi natural log A plus B by B di by dt is given by I naught omega cos omega t. So this is my answer for the first part. Now in the second part, we have to calculate the heat developed. Fine. So first of all, I assume that dH, that is a small heat that is produced in a small time interval, that is I square R dt. Fine. Where R is the resistance of the loop and I is the current through the loop. Fine. So I can write it as I square R dt integrated from 0 to 20 pi by omega. Now we calculate the EMF in earlier part, that is in A part, that is the EMF. So I can calculate the current as E by R. So that will be mu naught into A into I naught cos omega t divided by 2 pi R natural log of A plus B by B. This is the current flowing through it. So I do have mu naught into A into I naught cos omega t by 2 pi R natural log of A plus B by B whole square into R into dt integrated from 0 to 20 pi by omega. Now it is not possible to solve this equation over here due to the insufficiency of the page. So I'm directly writing the answer that comes out to be on solving this equation directly is 5 mu naught square into a square into I naught square omega divided by 2 pi r natural log or square 1 plus b a by b. That is my answer.